Hello everyone, this is a lesson on determining sum of the terms of a given finite geometric sequence. A geometric series is the sum of the terms of a geometric sequence. Suppose a sub 1, a sub 2, a sub 3, and so on with a sub n as our last term. If we are going to add these terms, we form a geometric series. Now, let us have an example on how to find the sum of the terms of a geometric sequence. Example number 1. Find the sum of the first 4 terms of a geometric sequence if its first term and common ratio are 3 and 2 respectively. So here we are going to start with the first term 3, and to obtain the next term we are going to multiply it by the common ratio, which is 2. So that is 3 times 2 equals 6. 6 is our second term, times 2 equals 12. 12 is our third term, then times 2 again, 24 is our fourth term. Now, we can easily add these numbers because they are small numbers anyway. So we have 3 plus 6 is 9, plus 12 is 21, plus 24 is 45. So our answer here is 45. How about if we are asked to find the sum of the first 20 terms, or even the first 100 terms? It's a tedious task to find all the terms and add them up. So if that would be the case, we need a formula, and we will explain the formula here. For our second example, let us use the same example we have, but this time we are going to find the sum of the first n terms. So these are our first 4 terms, 3, 6, 12, and 24. So a sub 1, a sub 2, a sub 3, a sub 4. We need more terms here so that our last term is a sub n. And because a sub n is our last term, our second to the last term is a sub n minus 1. Now the second term 6 can be expressed as 3 times 2 to the power of 1. And then the third term 12 can be expressed as 3 times 2 to the power of 2. And 24, the fourth term, can be expressed as 3 times 2 to the power of 3. And we have a pattern here. For the fourth term, our exponent is 3. For the third term, our exponent is 2. For the second term, our exponent is 1. So this means for our second to the last term, our exponent is n minus 2. And for our last term, our exponent is n minus 1. Now, we are going to find the sum of the n terms. This time, we are going to change our first term 3 here to be a, and the common ratio 2 to be r. So we have this representation. S sub n equals a plus a times r to the power of 1 plus a times r to the power of 2, and so on, so that our last term is a times r to the power of n minus 1. We are going to consider that this is our equation 1. We need another equation, and multiplying all terms by r, we have r times s sub n equals a times r to the power of 1 plus a times r to the power of 2, and so on, and our last term a times r to the power of n. And this is our second equation. Now we are going to subtract equation 1 minus equation 2. So this is what we get. S sub n minus r times s sub n. And when we are going to subtract the right hand side, so this means a times r to the power of 1 here on the first equation minus the a times r to the power of 1 on the second equation, that is 0, and a times r to the power of 2 on the first equation, and then also a times r to the power of 2 on the second equation equals 0. So that what will be left out here are just a and then a times r to the power of n. So we have here a minus a times r to the power of n because we are subtracting. Factoring s sub n minus r s sub n, we have s sub n times the quantity 1 minus r, and factoring a minus a r to the power of n, we have a times the quantity 1 minus r to the power of n. Now, dividing both sides by 1 minus r, that 1 minus r cancels out. So we have s of n equals a times the quantity 1 minus r to the power of n all over 1 minus r. Now, example number 3. Find the sum of the first 7 terms in a geometric sequence if its first term and common ratio are 3 and 2 respectively. This is the same example we have, but this time we will make it specific that we are going to find the sum of the first 7 terms. Our purpose here is to use the formula we just obtained. So s sub 7 equals 3 plus 6 plus 12 plus 24 plus and so on, so that our 7th term is 192. Now from here, we are going to consider this to be equation 1 and then multiply by the common ratio, which is 2. So we have 2 s sub 7 equals 6 plus 12 plus 24 plus 48 and so on, plus 384 as our 7th term here. This is our equation number 2. We are going to subtract now. So s sub 7 minus 2s sub 7, we have s sub 7 minus 2s sub 7. So the 6 on the first equation and the 6 on the second equation, that is 0. 12 on the first equation and 12 on the second equation, that is 0, and so on. And what are left out here are the first term on the first equation and the last term on the second equation. So we have 3 minus 384 because we are subtracting here. It becomes negative 384. S sub 7 minus 2s sub 7 equals negative s sub 7, and 3 minus 384 is negative 381. So dividing both sides by negative 1, so we have s sub 7 equals 381. Now, we will use the formula. This is our formula. S sub n equals a times the quantity 1 minus r to the power of n all over 1 minus r. So our a here is 3, okay, our r is 2, and our n is 7. So we have s sub n equals 3 times the quantity of 1 minus 2 to the power of 7 all over 1 minus 2. And simplifying furthermore, so 2 to the power of 7 is 128. So 1 minus 128 is negative 127. Now, 3 times negative 127 over negative 1 equals 381. This is what we get here. We can just simply use this formula to find the sum of the specified number of terms of a geometric sequence. Now, your turn. I prepared here 4 problems. You can pause the video and work on these 4 problems here. Use the given information in each item to find the geometric series. Number 1, a sub 1 equals 5 and r equals 2 and n equals 6. Number 2, a sub 1 equals negative 3, r equals 4 and n equals 5. Number 3, a challenge question. A sub 6 equals 729, r equals 3 and n equals 6. Number 4, a challenge question also. A sub 3 equals 1/2, a sub 6 equals 4, and n equals 7. Now I will show you the answer. Number 1, this is our formula. Substituting these known values to our formula, this is what we get. Simplifying furthermore, this is what we get. And our answer here is 189. Number 2, this is our formula. Substituting these known values to our formula, we get this. Then simplifying furthermore, we get this. And our answer is negative 1023. For example, number 3, our challenge question. We don't have a sub 1 here, so we need to find a sub 1 first. This is our formula. Substituting the known values we have here, we have 729 equals a sub 1 times 3 to the power of 6 minus 1. And then simplifying furthermore, we have 729 equals a sub 1 times 243. So 243 comes from 3 to the power of 6 minus 1. So 6 minus 1 is 5. 3 to the power of 5 is 243. Dividing both sides by 243, so our a sub 1 is 3. Now our formula is s sub n equals a times the quantity 1 minus r to the power of n all over 1 minus r. So substituting the known values along with a sub 1 here, so we get this. S sub 6 equals 3 times the quantity 1 minus 3 to the power of 6 all over 1 minus 3. Simplifying furthermore, we get this. S sub 6 equals 3 times negative 728. Negative 728 comes from 1 minus 3 to the power of 6. 3 to the power of 6 is 729, so 1 minus 729 is negative 728. Now simplifying furthermore, that means 3 times negative 728 divided by negative 2, our answer is 1092. For item number 4, a challenge question, we don't have a sub 1 either. So we are going to find a sub 1. And we can illustrate the terms of our geometric sequence as we don't know a sub 1, we don't know a sub 2, this is our a sub 3, we don't know a sub 4, we don't know a sub 5, our a sub 6 is 4. So here we can just let 1/2 to be our a sub 1, and we can also let 4 to be our a sub 4. And using the formula a sub n equals a sub 1 times r to the power of n minus 1, substituting these known values we have here, we have 4 equals 1/2 times r to the power of 4 minus 1. Simplifying furthermore, 4 minus 1 is 3, so we have 4 equals 1/2 times r to the power of 3. So getting rid of 1/2, we are going to multiply both sides by 2 over 1 or 2. We have 8 equals r to the power of 3. And the cube root of 8 is 2. So we already know our r, which is 2. We can move backward from 1/2. So we are going to divide it by 2 to obtain the preceding term, so it's 1/4. Again, we can divide 1/4 by 2 to get the preceding term, which is 1/8. So 1/8 is our a sub 1. Now our formula is S sub n equals a times the quantity 1 minus r to the power of n over 1 minus r. Substituting the known values we have here along with r, which is 2, we have this. S sub 7 equals 1/8 times the quantity 1 minus 2 to the power of 7 over 1 minus 2. Simplifying furthermore, we have 1/8 times negative 127 over negative 1. So negative 127 comes from 1 minus 2 to the power of 7. 2 to the power of 7 is 128, so 1 minus 128 is negative 127. And the denominator, 1 minus 2 is negative 1. And simplifying furthermore, we have 127/8 as our answer. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.